Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 6-1, integer exponents. Alright guys, so the table below shows powers of 5, 4, and 3. What pattern do you see in the powers of 5? What do you guys see? It's like as the exponent decreases by 1, the value of the power is divided by 5. Right, so 5 to the first is 5 times itself once. Anything to the 0 power is 1. 5 to the negative 1 is the same thing as 1 over 5 to the first, right? So anytime it's a negative exponent, it's 1 over that number to the positive exponent. This is 1/5, 1/4, 1/3. 5 to the negative 2 is 1 over 5 squared, or 1 over 25, 1 over 16, 1 over 9. Right? 1 over 3 squared, which is 1 over 9. What pattern do you see in the powers of 4? So as the exponent decreases by 1, the value of the power is divided by what? By 4. Complete the tables for 5 to the negative 1, 5 to the negative 2. Complete it for the 4s and for the 3s. Write a general rule for the values of a to the 0. So anything to the 0 power is? And any negative exponent is 1 over the number to the positive exponent, right? So anytime it's like a to the negative n, that's 1 over a to the n. Okay, so that's that rule. And anything to the 0 power is 1. Do the general rules you wrote in part F for a to the 0 and a to the negative 1 apply when a equals 0? Explain. So they're saying, what is 0 to the 0 power? So it's no. If a equals 0, then it's 0 to the 0 power. But 0 times any number is 0. So 0 to the 0 cannot be 1. If a equals 0, then a to the negative n is 0 to the negative n, which would be 1 over 0 to the n, and you can't have 0 in a denominator, which would be undefined. You can't have something out of nothing, right? You can't have a 0 in the denominator. Complete the following equations. All right, so 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5 of them. It's 3 to the 5th, right? This is 1, 2, 3, 4 of them. 3 to the 4th times 3, which is how many of them total? 3 to the 5th. Right, there's 4 of them and 1 of them, so there's a total of 5 of them. there's 3 of them, and 2 of them, and 3 plus 2 is 5 of them. So did you guys see the pattern? So it's basically, you add the exponents, right? When multiplying exponents with the same base, you add the exponents. Use your pattern to complete this equation. 5 squared times 5 to the 5th, there's 2 and 5 of them, there's 5, 6, 7 of them, right? Because if we had 2 of them, times 1, 2, 3, 4, 5 of them, there's 1, 2, 3, 4, 5, 6, 7 of them. Make sense? You can always expand it out when you forget the rules. Write a general rule for the result of a to the m times a to the n. It'd be a to the m plus n, right? You add their exponents. What do you see when you're dividing two powers with the same base? There's 5 of them and 3 of them, and you can cancel 1 for 1. So you're left with 2 on top. When dividing exponents with the same base, you subtract their exponents. So a to the m divided by a to the n is a to the m minus n. When you have an exponent to an exponent, that's basically saying that we have 5 times itself 3 times, and we have 2 sets of those, right? Because this squared is this times itself twice. So there's 6 of them, right? Exponent to an exponent, you multiply. When you have an exponent to an exponent, you multiply. When you have an exponent to an exponent, you multiply. So that's saying that it's 5 and then 3 times 2, 5 to the 6th. Four times 2, 8. So a to the m times n. 7 to the 8th, right? A to the m times n. Do the general rules you wrote in parts A, B, and C apply if A equals 0? Explain. Assume that M and N are not 0. Okay, so what was part A? Part A was, okay, so if A equals 0. So this one is just saying, in part A to the m plus n. If a is 0, it would just be 0 to the m plus n. And 0 to anything is just going to be 0. So yeah, it works. It's just going to end up being 0. How about for part B? For part B was a to the m minus n. So that's going to be 0 to the m minus n. So yes, it works. It'll just end up being 0, right? 0 to anything is just going to be 0. And then for C, m to, like that, so that's going to be 0 to the m n. Well, 0 to anything is just going to be 0, so yeah, it works. So it definitely works for A and C. Wait, looking at B, before I go to here, what about when it's like this? A to the M over A to the N. Can I have 0 to the M over 0 to the N? Can I have 0 in a denominator? It would be undefined. Darn it. I almost fell for that. I did fall for it. Right? Because of the fact that it was division and they're saying that I would have had a 0 in the denominator, you can at no point ever have a 0 in the denominator because it's undefined. You can't have a 0 in the denominator. All right. So, going back here. 5 minus 2 is 3. 5 plus 2 is 7. Anything to the 0 power is 1. 1 over 3 to the 8th, right? And that's 3 to the 5th. All right, so that's really it's hard to see what they want me to have where. 3 to the 5th plus 1 over 3 to the 8th plus 1. So 5, take these 5 away from here, and you have 3 left. So 1 over 3 to the 3rd plus 1 would be 1 over 9 plus 1. 1 is the same thing as 9 over 9, right? So 1 over 9 plus 9 over 9 is 10 over 9, which is 1 and 1/9, right? 9 could go in there once with 1 left over. All right, so on this next one, 10 minus 6, don't pack up until I tell you to do so. I have 2 minutes. 10 minus 6 is 4. 10 plus 2 is 12. 4 to the 3rd is 4 times 4 times 4. I said to stop packing up. Thank you. 4 times 4 times 4. Are they actually having me solve this or not yet? So 4 to the 3rd times 4 squared. 3 plus 2 is 5, right? 12 squared. 12 squared is 144. 4 to the 5th. 16, 16, and 4. 16 times 16 is 256 times 4. Or you can use your calculator and do 4 to the 5th, and you get 1024 plus 144 is 1168. So if they wanted you to solve it fully, it's 1168. Describe a method you could use to simplify each expression above that does not use properties of exponents. So after simplifying within parentheses in both cases, you could either evaluate each of the exponential expressions, do not leave until I tell you to do so, separately, and then continue to perform arithmetic operations on those evaluated numbers. So that is everything for today's lesson. I hope you guys enjoyed the